Hey, it's Mrs. Golding. We are in your math packet and we are on page 12. We are doing problem number 1. This is part 2 of that video. So as you know, we discussed the shape and center of our data, and we represented this data saying that it is a normal distribution. It is pretty symmetrical as it relates to that normal bell curve. If you look at the mean of the data, which is represented here, that would be a representation of the center of the data, as well as the mode and the median and mode. So if you take that data on your piece of paper and you look at it, the one that is in the middle, so it'd be the 13th piece of data in order from least to greatest. Since there's 25, 13 would be right in the middle. That is a 17, so that's my median. And my mode is the piece that happens most often, which would be 18. I believe it occurs 1, 2, 3, 4, 5, 6, 7, 8 times. Now, there's a couple of other words here that are kind of neat. With regards to the concept of variability, so our data is pretty closely gathered or closely, I'm trying to think of a better word. It's kind of all stuck in the middle, in this middle frequency interval. And so that means it has little variability. It doesn't have a lot of what we would call outliers. There's no like 30-pound puppy, and there's no like 5-pound puppy, a tiny little runt. So our variability is small. And we see that here with a standard deviation. So the standard deviation is how different it is than the mean or the average. And most of these are pretty similar. So this is a pretty low number, so the variability is low. This here for skewness does it skew left or right? And you talked about this in class. And this has a negative value, and it's a pretty small negative value. So that means it's slightly skewed left, but not very much at all. Not very much at all. Kurtosis just means talking about how heavy the tails are. And the tails are down here, right? The tails are how these, and it's usually when there's outliers. This kurtosis is very small. A normal kurtosis is a value of 3. This is very small. So the tails are very, very, very light. Okay. Again, that's an idea of variability. Everything is kind of squished in the middle. Okay, the other way you can look at variability is to take the range, which is the highest, and they call it a score, but it's a weight, minus the lowest weight, and that distribution range was 7. That's pretty small for our data. So variability is low. It says, what is a typical birth weight for puppies born at this kennel? And explain why we chose this value. Typical is in statistics is generally in reference to the mean. And so I'm going to round that to 17. So I'm going to say the typical birth weight for a puppy born here is 17 ounces. All right, I think we've answered all of our questions with regard to this this problem in our packet, and hope you learned some interesting thing about statistics. Enjoy.